Dear students, in the previous session, I have started the second method of solution of the differential equation. The type of equation that we were considering were called as the linear differential equation. Okay, and I told you the procedure. It has to come to the standard form dy by dx plus py equal to q, where p and q are either constants or functions of x only. Then we calculate the integrating factor and also the solution. We have done some problems. In this session also, I am going to work out the same type of problem. First I calculate the general solution, then I move on to the particular solution. Now here, at present I am calculating the general solution, that is x into log x into dy by dx plus y is equal to 2 log x divided by x. Now it is not in the standard form. The coefficient of dy by dx is x into log x. Therefore, first divide by x into log x. Okay. Then this term becomes free from that one. Dy by dx plus y into, or you can write y divided by x into log x, and right hand side 2 log x by x is already there. When you divide by x into log x gets cancelled and what remains is 2 by x square. So this is the, now I can write the value of p. What is p? P is the coefficient of y, that is 1 by x into log x, and q is 2 divided by x square. Next, what we have calculated, integral p dx. Okay, integral p dx. What is the integral of p dx? It is 1 by x into log x into dx. Now here, let me write it properly. This is 1 over log x into 1 by x into dx. Now here we have to make use of the substitution method, that is when you take log x to be equal to t, the 1 by x dx becomes dt. Therefore, the function takes the form 1 by t. 1 by t means it is, or you can show that the substitution also, let log x be equal to t, then 1 by x dx be equal to dt. The function now has become 1 by t dt, whose integral is log of t. But what is t? It is log of log x. It is log of log x for both of them, e being the base here. Now here I have calculated integral p dx, isn't it? Now what is next problem? Next I have to find out the integrating factor. So the integrating factor is equal to e to the power p dx. Now p dx has been calculated, e to the power log of log x to the base e. In earlier problems I told you that e to the power log of some function to base e, if the base and the base both the places are equal, the function, the value would be equal to this one, whatever it is. In this case it is log x itself. So the integrating factor is log x. Now let me write the solution. What is the solution? Y into integrating factor. What is the integrating factor? It is log x, that is equal to q. What is q here? 2 by x square into log x, isn't it? Into log x, the integrating factor, into dx plus the constant of integration. Now here the left hand side already an integrated function, right hand side we have to integrate. Let me rewrite the function. Take 2 outside, write it as log x into 1 by x square into dx. Now which method of integration? We have to use the integration by parts, that is it is 2 into, 2 is applicable to both the terms, so write a bracket here. First function log x into integral of the second. For 1 by x square, the integral is minus 1 by x, minus of integral of minus 1 by x. Whatever is there, write it as it is. Log x has the derivative 1 by x into dx. Okay. Then, of course, here you have to write the constant, that is continuing there. Therefore, I can write here y into log x, that is the left hand side. Right hand side 2 into, there are two terms here, both of them should be multiplied by 2. First we write minus, there is a minus sign here, minus 2 into log x divided by x. Then 2 into minus of minus plus, that is 2 into integral 1 by x square into dx plus the constant. Now again it is minus 2 log x divided by x plus 2 into, again the integral is minus 1 by x plus the constant. So what we are having now, it is y into log x equal to minus 2 log x divided by x minus 2 by x plus the constant. Now this is the general solution of the function, that is we have calculated the first we have calculated integral p dx, and then we have calculated the integrating factor, then we have started with the solution. So it is y into log x equal to minus 2 log x divided by x minus 2 by x plus c. You can stop here, but right hand side we see that there is a common factor. Let me take that common factor and write the remaining terms. What's the common factor? It is minus 2 by x into log x plus 1. It is not log of x plus 1, it is log x plus 1 plus the constant of integration. So this is the general solution of the given function. So if the given function, if the given equation is not in the standard form of a linear differential equation, first you have to divide by the coefficient of dy by dx and try to bring it to that particular form. Now let us move on to the next problem. Here also we have to make some adjustment to bring it to the standard form. Now the problem is like this: 1 plus x square into dy plus 2xy into dx, that is equal to cot x into dx, x not equal to 0. You observe here x and dx and dy are not at all together. So first step is we have to try to write in the standard form where dy by dx should appear in the equation. Now look here, there are two terms containing dx. First take them together on the same side and then we try to bring it to the standard form. 1 plus x square into dy plus 2xy dx minus cot x into dx, okay, that is equal to 0, or you can take this also to the right hand side. Now it is 1 plus x square into dy plus take out dx as common factor. What is remaining now? 2xy minus cot x equal to 0. Since I want dx here, because I should have dy by dx here to bring it to the standard form, first what I have to do is divide by dx. Right hand side is 0, we can do all those calculations easily. 1 plus x square into dy by dx is equal to, when it is divided dx gets cancelled, it is plus 2xy minus cot x equal to 0. Now first step is take cot x to the right hand side. It is 1 plus x square into dy by dx plus 2xy, that is equal to cot x. Now even now it is not in the standard form because we should have the coefficient of dy by dx to be unity. Therefore divide by 1 plus x square. When you divide by 1 plus x square here, this would become dy by dx plus 2x divided by 1 plus x square into y, that is equal to cot x divided by 1 plus x square. So finally we have brought it to the standard form of a linear differential equation, so that I can identify what is p and what is q, and finally I can get integral p dx as well as the identifying factor. Okay. Now let me write the values of p and q here. What is P here? P is 2x divided by 1 plus x square, and Q is cot x divided by 1 plus x square divided by 1 plus x square. Now, our first problem is to find integral P dx, isn't it? Now, what is integral P dx here? P is 2x divided by 1 plus x square into dx. And again here, what method you can adopt? You look at the denominator. Suppose you take 1 plus x square to be equal to t, whole of the numerator becomes dt. That means, if you want, you can show that in the working column also. 1 plus x square equal to t means 2x dx would be equal to dt. Therefore, the function reduces to 1 by t into dt. Now again, it is a basic function, hence the integral becomes log of t. What is t here? It is log of 1 plus x square. So whenever you write logarithmic function, write the base to be equal to e. Now this is the value of integral p dx. But what do you want now? The next step is integrating factor. What is the formula? E to the power integral p dx, that is e to the power log of 1 plus x square to base e. See, we have come across this type of term enough number of times in the earlier problems, where what I have told you, it would be equal to 1 plus x square. So we got quite a simple term as the integrating factor. Now let us try to write the solution. So we have now calculated integral p dx as well as the integrating factor. So what is remaining now? We have to find the solution. The solution is y into the integrating factor. What is that one? 1 plus x square, that's equal to integral q. What is q? Q is cot x over 1 plus x square into the integrating factor is 1 plus x square into dx plus the constant of integration. But when you do this one, first always you have to write the formula. Y into integrating factor is equal to integral q into integrating factor into dx plus the constant. Then only you write the one which is connected with this particular problem. So these two can be cancelled. So what is the integral of cot x? It is log of sin x plus the constant. So it is y into 1 plus x square is equal to log of sin x plus the constant is the solution. Now you can stop here. Okay, this itself is the solution. If you want only y on the left hand side, you can divide by 1 plus x square. Okay, then it becomes y is equal to log of sin x divided by 1 plus x square plus c divided by 1 plus x square, or you can stop at this stage also. That is the solution. If you want to write only y on one side and write the other terms on the other side, then you can do this one. Now this is another type of problem where both dx and dy were not together. We did not have dy by dx at all, isn't it? First, it has to be brought to, that is, that ratio dy by dx we should have. Then only we can identify with the values of p and q. Then we can do the remaining calculation. Now let's move on to the next problem. Next problem also the same type of situation is there, where you have to readjust the terms to get the values of p as well as q. Here x into dy by dx plus y minus xy cot x is equal to 0. Again the condition, x is a non-zero real number, non-zero quantity. Okay. See, in the previous problem, each problem I am taking a little bit a different problem. Now in the previous problem, dy and dx were separated, so I have to bring them together. Okay, to bring it to the standard form. Here dy by dx is existing, but here this term, where what we denote it as py, should have only one term p, that is y is present in both the terms. First let us take out the common factor. Take out y, it is 1 minus x cot x, okay, that is equal to 0, okay, because this term should be of the form p into y, and that p should be containing only x or constant, as you know. Now almost it is in the standard form, but for only thing the right hand side 0. At present we divide by x here, that is dy by dx plus y into there are two terms here, divide both of them by x, that is 1 by x, and x is cancelled here, it is cot x, that is equal to 0, okay, that is cot x, that would be equal to 0. Now just a minute, one term one term I have missed here. There is one more term here in the problem. I will rewrite that one. Because of that one, no, I could not correct it. Here, not only plus y, there is one minus x also. Otherwise, again it would be a combination of, the term will not be free here. One term I have missed here. It is minus x is also present in the problem. X into dy by dx plus y minus x plus xy into cot x here. So this minus x, first I have to shift it to the right hand side. Otherwise you cannot separate the terms and take these two. Out of these two, we are having a common factor 1 plus x cot x. Okay, and this minus x I am shifting it, so that it has almost come to the standard form, but for one thing, that x is the coefficient of dy by dx, which should not be present there. Okay, now divide by x, therefore dy by dx plus y into, here there are two terms inside the bracket, divide both of them by x, that is first one becomes 1 by x, second one x into cot x by x, that x is cancelled, cot x is remaining, right hand side x by x, that is 1. Otherwise, now if minus x is not present in the problem, we don't get the given function, given equation in the standard form. Now you can identify the values of p and q. What is p here? P is the coefficient of y, that is p has got the value 1 by x plus cot x, and what is q? Q in this case is a constant. I told you already, p and q would be either constants or functions of only x. Now let me consider integral p dx. Integral p dx, that is integral 1 by x plus cot x, okay, into dx. Now let us individually integrate them. What is the integral of 1 by x? It is, as you know, log x. And what's the integral of cot x? That is also a standard function. It is log of sin x. I told you already, even if the base is not written, it has to be understood that the base is the general base, that is e. Now look here, both the terms are logarithmic terms of the form log m plus log n. So you can make use of the first law of logarithm. I can write it as log of m into n, that is x into sin x to the base e. Okay. Now this is integral p dx. You cannot do further simplification, keep it as it is. Now let me consider the integrating factor. What is that one? E to the power integral p dx, that is e to the power log of x into sin x to the base e. See, we have come across this particular type of term many times. So wherever some functions are connected with the log functions are there, we can use that information. And what's the value of this one? It is nothing but x into sin x. We can write that one. Now the solution. What is the solution? You know the formula, y into the integrating factor, that is equal to integral q into the integrating factor into dx plus the constant. Now let us write the actual values of the value of the integrating factor and do the integration of the right hand side. Now integrating factor is x into sin x, that is y into x into sin x integral of, what is q here? In the function we have seen that q has got the value 1, isn't it? And what is the integrating factor we have got here? It is x into sin x into dx plus the constant. So what's the function which has to be integrated now? It is integral x into sin x. What method you can adopt? The integration by parts. Now take the first function as x, integrate the second function, that is minus cos x. Then that is first function into integral of the second, minus of my integral minus cos x into derivative of x is 1 into dx plus the constant. Hence it is minus x cos x minus of minus plus the integral of cos x is plus sin x plus the constant. And what did you have on the left hand side? It is y into x into sin x. Now we can do some simplification here. What can be the simplification? Divide by x into sin x. I told you already, as far as possible, we try to write the answer y is equal to some function. When you divide by x into sin x, y remains on the left hand side, minus x is cancelled, cos x by sin x, that is cot x. Next, sin x and sin x, they get cancelled, and it is 1 by x. The last one is c divided by x into sin x. Now this is the solution. Of course, that the earlier statement is also the correct solution only, but here I told you already, we generally write this one. Now you can stop here, or generally you know that we start always with the positive term. So you can write like 1 by x minus cot x plus c divided by x into sin x, or you can write c by x into 1 by sin x can be written as cosecant x also. These are the different ways of expressing the answer, but as it is, even if you stop here, the answer is complete. Okay. So these are the problems where we have made use of the linear differential equation, but in all of them now I have calculated the general solution. What do you mean by the general solution? When you do the integration of the function, then we always get an arbitrary constant, that is called as the general solution. When a particular value for x and also for y are substituted, then we get the value of c, automatically it will be called as a particular solution, okay, because we know the exact value of c. So we have done the same type of problem in the earlier method, that is where the variables are separable. Now the same type of problem I am going to work out in the case of a linear differential equation, okay. Now here find the particular solution. Particular solution means what has to be given? After giving the equation, the values of x and y should also be specified in the problem. So the problem is like this: find the particular solution of the differential equation dy by dx plus 2y into tan x is equal to sin x. Under what condition? What are the values that would be given here? Y is equal to 0 when x is equal to pi by 3. When x is equal to pi by 3. You can look here, both p and q are here trigonometric functions. Therefore, the value of x is given in terms of an angle. Now, let us see, you can observe that the function is already in the equation is already in the standard form. So directly we can get the value of p. What is p? But for y, whatever is present, that is p. So 2 tan x and q is equal to sin x. Okay. Now calculate integral p dx, that is integral 2 into tan x into dx. Okay. Now keep the 2 outside. What's the integral of tan x? It is log of secant x, okay, to base e. Now here in the earlier problems, Whenever we got log m plus log n, we have used the first law of logarithm. When we got log m minus log n, we have used the second law of logarithm. Look here, I am using the third law of logarithm. According to that one, log m to the power n is n into log m. That is, if the power is there, it can be taken as a coefficient, or the coefficient can be taken as a power of that number. That means you can write it as log of secant square x to the base e, that is integral p dx. Now let me consider the integrating factor. What's the formula? E to the power integral p dx. What is that one? E to the power log of secant square x to base e. Again, I have told you, using that information, the integrating factor has become here secant square x. Now let me consider the solution. So y into secant square x, that is the integrating factor, that is equal to q. What is q here? In this equation, sin x into secant square x into dx plus the constant of integration. Now right hand side, see, as it is, you cannot apply any method like substitution or anything. But let me rearrange the terms of the integral. It comes to one of the standard formula. Here what I do is, I keep sin x as it is, secant square into secant square. One secant x I write here, another secant x I write separately. You know that secant x and cos x are the reciprocal ratios. That means sin x into the secant x, we write it as 1 by cos x into secant x into dx plus c. What is sin x by cos x? It is tan x. So integral tan x into secant x into dx plus c. The left hand side is y into secant square x. Clearly you can see that it is one of the standard integrals. In the beginning of integration, you learnt about this one. Integral secant x into tan x is nothing but integral, it is the integral of secant x plus the constant. So y into secant square x equal to secant x plus c. Now this is the general solution. But what I have told you in this problem, you have to get a particular solution. What are the values here? When y is equal to 0, when x is equal to pi by 3, y becomes 0. So wherever x and y are there, write those values. Write y is equal to 0 and x is equal to pi by 3. Now left hand side, 0 into secant pi by 3 the whole square. That is equal to right hand side also secant pi by 3 plus the constant. When 0 into anything, that becomes 0. Secant pi by 3, that is secant 60, has got the value 2. So it is 2 plus c, which implies that c is equal to minus 2. Now substitute this value in that equation. That is, put c is equal to minus 2 in the first to get the particular solution. That is, y into secant square x is equal to secant x minus 2. Here again I told you to write in the proper form. In a neat form I can say, I can divide by secant square x. When you divide by secant square x, both the sides, left hand side secant square gets cancelled, one secant x is cancelled. So you can write 1 by secant x. Here 2 divided by secant square x. Again I am using the fact that secant and cos are the reciprocal ratios. So 1 by secant x means cos x and 2 into cos square x. Now see, we got quite a simple function. That is, y is equal to cos x minus 2 cos square x is the particular solution. See, till now we are calculating the general solution. So this is the particular solution of the given differential equation. Now another problem where we will be calculating the particular solution. Okay. Now, again this problem it is not directly in the standard form, you have to bring it to the standard form. So, find the particular solution, the data I will be giving you, find the particular solution of 1 plus x square into dy by dx plus 2xy, that is equal to 1 divided by 1 plus x square. Y is 0 when x is 1. When x takes a value 1, y takes a value 0. Now, you observe that dy by dx is having a coefficient other than unity. Therefore, first step is you have to divide by 1 plus x square. Divide by 1 plus x square. So, the left hand side first term is dy by dx plus 2x divided by 1 plus x square into y, that is equal to 1 by, already 1 by 1 plus x square is there, that becomes square of that one. Okay. Now, you can identify what is p and what is q. What is p here? It is 2x divided by 1 plus x square, and what is q? Q is 1 divided by 1 plus x square the whole square. So, we got here the values of both p and q. What is the next step? You have to calculate integral p dx. This problem is again quite lengthy, especially when you are calculating the particular solution, it would be rather lengthy. Integral p dx is integral 2x divided by 1 plus x square into dx. The same type of function just now we have come across in one of the earlier problems. By taking this as a t, whole of the numerator becomes dt. So, the function reduces to 1 by t, the integral being log of t, and so I am writing this as log of 1 plus x square to the base c. Just now in the same session in the previous problem I have come across this one. Now, let me write the solution. So, first I am to write the integrating factor, which is e to the power integral p dx. Now, here write it as e to the power log of 1 plus x square to base e. Now, just now the same information, e power log x to base e is equal to x itself, in this case this being 1 plus x square. Therefore, the solution is y into the integrating factor, that is 1 plus x square, that is equal to q. What is q? Q already has been calculated. It is 1 over 1 plus x square the whole square. And what is the integrating factor? It is 1 plus x square into dx plus the constant. Now, one term can be cancelled. So, what is remaining now? 1 divided by 1 plus x square dx plus the constant. Now, you can see that it is again one of the standard values, standard functions whose integral is tan inverse x plus the constant. So, this is the general solution. Y into 1 plus x square equal to tan inverse x plus the constant. Always give a number for this one because we have to refer it afterwards. Now, let us come to the values that have been specified for in this particular equation. What are the values? Y takes the value 0 when x takes the value 1. That is, put x equal to 1, y equal to 0. Left hand side 0 into 1 plus 1 square. Right hand side tan inverse of 1 plus the constant. Now, 0 into anything, that is 0. What is tan inverse 1? Inverse trigonometric function, this is a standard value. It is pi by 4 or it is 45 degrees, which implies that c is equal to minus pi by 4. C is equal to minus pi by 4. Substitute this value in result 1. Therefore, the result 1 becomes here y into 1 plus x square, that is equal to tan inverse of x minus pi by 4. minus pi by 4. No other simplification is necessary, that is dividing by 1 plus x square. Even if you divide by 1 plus x square also, that does not come to any simplified form. So, there is no use in that one. So, you can stop here, y into 1 plus x square equal to tan inverse x minus pi by 4. So, this is the particular solution for this problem. So, like this, whenever we come across the linear differential equation, they can ask you to find the general solution or the particular solution. Okay, general solution means one step is less, that's all. Particular means one more step, you have to substitute the values of x and y and evaluate, see, again write it in the general solution, that becomes the particular solution. So, this completes the second method of solution of the differential equation. We have been left only with one more type, that is homogeneous differential equation. Generally, in all the earlier examinations, they have asked about the first two methods, that is the way the variables are separable and the linear differential equation, one for 3 and one for 5 mark questions. Now, in the next session, I am going to teach you about the homogeneous differential equation, what is the definition of that one and how to solve that equation. Thank you.